Hello again, everybody. Dr. Jim here. The purpose of this video is to go through the course syllabus and some of the other business documents in a manner that I would do typically on the first day of the course. Again, you'll see that I'm here in my living room. The Christmas tree is still behind me over there. When I do that, the background gets high. So before you go through this, I'd like you to make sure you have three things here. One of them is the course syllabus, which I have up here in the frame. The other two things, which I'll talk about a bit at the end, are this PDF of sort of a visual calendar of the course, which sort of gives us the big picture of things, although it's a little short on details. And then the day-by-day to-do list, which I will go through in a frame towards the end of this pair of videos, pair if it doesn't fit into one, just to make sure we understand how the business of this course goes. So what I'm going to do here is just kind of scroll through this and talk about the various parts. When I get a ways in, I'm actually going to splice into some things from last summer's version, just because I thought when I talked about what the course is trying to do that went over very well, and I just as soon keep it rather than do it again and make it worse. So here we go. This is the winter version of Chem 127. This is the course syllabus on the frame here. Again, I'm Dr. Jim. There's where you can find me. Office hours is something I normally list on this. There is several ways to get help in this course. One, there is a open question board on the discussion board, and I encourage you to use that because several people might have the same question, and then we can help several people at once. And sometimes your fellow classmates learn from seeing people ask good questions in as much as they learn from the answers. You can always email me, and actually I am on campus during winter and most of the time, so if you're local, you're welcome to stop in. It's really nice to actually see faces of students from time to time. The schedule and the pace, I'll go through this again in a bit again, but we have this day-to-day planning document, as I said before, and this sort of broad calendar. Print these will change from, may change from day to day as we make some adjustments to the pace and things like that. But generally the course goes like this. Basically every day you need to watch a video lesson. About every other day you need to do a discussion, although the discussion windows are flexible enough so that they actually extend over the adjacent days, but it's approximately one every other day. And there's two additional written assignments that sort of fit in between the quizzes and tests, in addition to a couple of quizzes and a couple of tests. But that's the sort of rhythm of the course, if you will. There's two primary texts, which you should have from the bookstore. One of them is called Chemistry in Context. That's written by my professional association, the American Chemical Society, and my opinion is that in terms of a simple chemistry book, it's really solid. In terms of context, I believe it kind of sucks. So we'll take the chemistry out of the context and use it from there, although there are chapters on ozone depletion and global warming and the like. So there is some context there, and if you find it valuable to read, go ahead and read it. Our primary discussion text will be this thing called Field Notes from a Catastrophe. This is a really interesting journalistic account of climate change. Most of you in this course come from outside Phillips Hall and are therefore directly involved in studying the human enterprise of one form or another, and this really comes at the issue from a human perspective, both from a scientific perspective as well as sort of a political cultural perspective. And it's written in a journalistic style which is really down to earth, and it really reports on the issue from the people, so I like it. Interestingly, some people talk about how this book is a little old at this point back in 2006. Just between you and me, the science hasn't changed that much since then. But this is a really solid text. I will give you PDFs from a couple of other kind of environmental chemistry and meteorology books when the time comes. You'll see links to those in the lessons. You will need a scientific calculator. What I mean by scientific is it needs to handle numbers in scientific notation. And we deal with a lot of big numbers when we deal with the climate. We deal with a lot of small numbers when we deal with molecules. And I would say learn how to use the scientific notation feature in there. You don't have to write 8 times 10 y to the x. There's usually a little button that says EE, which will give you the numbers directly in scientific notation. It'll make things a lot easier to deal with. send me an email or something if that doesn't make any sense. Here's what our grade is based on. We got a couple of 30-point quizzes, a couple of 60-point tests, and a final essay. That essay will be on you making the case for the scientific case for global climate change. These add up to just under 320 points. Notice that I assign homework sets with every issue. I'm just going to fix that right now. They're not turned in. The homework assignments are, you do them. I would even print them out before each lesson and follow along and pause the video and do the homework assignment, or do it however you want to do it. That's one of the nice flexible things about an online course. Those are the key to the quizzes and tests. If you can do the homework assignments, you can do well on the quizzes and tests. You'll do great in the course. And the intent is to be very, very straightforward. And I'm very clear about what homework assignments correspond to which lessons and homework assignments are on the quizzes and tests. So just because the homework isn't turned in, don't think it's optional. That's the key to your success in the course. Okay, I mentioned the quizzes and exams. There's the dates. The final exam essay will be worth 20 points. There's a couple of these things called miscellaneous written assignments. One of them is you'll actually do a personal carbon inventory. Another one is that you will review the web page, a couple web pages of organizations that have an opinion on climate change, and try to, decide whether they're legit or not, is the basic idea. I'll talk about discussion below. The last two things here are actually things the university requires me to have, like an attendance policy. It's an online course. I'm assuming you're going to log into the website, into the D2L site, and watch the videos. Obviously, I'm not going to take attendance. That's my policy. Special needs, I have to have the statement of special needs. I'm guessing that if you do have special needs, then an online course probably gives you the flexibility you need. Okay. Now I'm going to splice over to the video from last summer in which I talk about the course. What are we doing in this course? Okay. So in the business, we would say, what are we trying to do? We would state them as goals and outcomes. Goals being more general, outcomes being specific. Really what we're trying to do here is understand global climate change. What is climate? How does the system function? What factors affect change? So there's an understanding the Earth and how the Earth works part of this. And that's that's a knowledge piece. Our first UWEC learning goal is that you know stuff, and you at the end of this course you will know stuff about chemistry and how the climate system works. In a more intangible sense, we want to gain some perspective on where we are from the standpoint of sustainability. Sustainability means that we can meet our needs and the needs of future generations without compromising, or meet our current needs without compromising the needs of the future generations. And this is really interesting because this climate change shows you how an objective direct chemical measurement can show you whether you're living sustainably or not. And that is to say that if carbon dioxide concentrations in the atmosphere are going up because of fossil fuel use, we are not living sustainably. And if carbon dioxide levels are staying flat and temperature staying flat, we are living sustainably. So this is a real sort of cut and dry chemical take on sustainability, all right? And you'll see the role that these objective scientific measurements sort of have really cosmic ramifications for the state of the human race. That's why I like to call that perspective, right? Not that there's no place for belief systems, but you can believe that the human race is not big enough to alter planet Earth on a global scale. In a science class, we kind of try to push those belief systems aside and look at what the data tells us. And here the data tells us that we're altering the global climate system with what we do. And you will see that pretty clearly, I think, by the end of the semester, or the end of the term. This issue connects to a lot of different things, and some of these other UWEC learning goals sort of foster a connection to those other things. I mean, one of the things is critical thinking, right? And I got at this a little bit before, we've got this really muddy issue, global climate change. Some people say that we're going to die next year, and some people say it's not a big deal and we shouldn't be worried about it. And that raises the question, who do you trust? How do you find the truth? Okay, this is an intro course. We got to start cultivating these things, and especially that organization essay will challenge you to do that and how to evaluate information that you see in various places. So, this is our UWEC learning goal says that we need to think critically and creatively. There's a little bit more critical thinking here, okay? And this is really information literacy. Who do you trust? How do you ask questions about what somebody's telling you along the lines of whether you should believe them or not? The other thing here is that as we look forward for climate change and we start contemplating things like a need to reduce fossil fuel use, once you make the connection between that fossil fuel use is energy use, and energy use is economic development, and economic development is quality of life, immediately we run headlong from this objective scientific, hey, there's too much carbon in the atmosphere, to, what is fair for all the nations in the world. And we got to start thinking about what is fair for us and people in third world countries in terms of trying to reduce CO2 and what level of personal sacrifice we're willing to make. So this gets really heavy. On the other hand, it's, these are questions that your generation is going to have to deal with. And this gets at the UWEC learning goal of individual and social responsibility. So we sort of do 4 of the 5 here. Some of my students have said that they have picked up a little of our diversity goal through our discussion text, because it does talk a lot about how people in different places are affected by this issue. So maybe we even do a little bit of that. At this point, I think a natural question would be, why the heck is this a chemistry course? Again, this issue touches on all the disciplines in the sciences, and once you go start looking for solutions to the problem, you end up in every discipline in the entire university. But the core of this thing starts from a chemical question, and that chemical question is, will fossil fuel use change the chemical composition of the global atmosphere and in turn change average global temperature? So when we're talking about changing chemical composition, that's definitely a chemistry issue. Okay. So here's some more specific things that we're trying to do here. You're going to understand the factors that affect the climate system. You're going to understand how these processes manifest themselves in the climate system and what has been their net impact over the last 150 years, i.e., how do changes in this and that and the other thing affect the climate, and what is the bottom line in terms of the changes we've seen over the last 150 years. You're going to come out of here with that if you want it. That's good knowledge to have. How and why are these factors are changing, both the human and natural effects? What are the magnitude of the observed changes? How much climate change have we had? How much do we expect in the future? And again, this bit about how the scientific aspects of climate change interface with other disciplines. Economics, politics, ethics, business, marketing, and maybe even your own major. That's sort of the hope.